Welcome to today's lecture. Myself, Assistant Professor Tukur Gupta from Ajay Kumar Garg Engineering College, Ghaziabad, and I am presenting the lecture series on the subject microprocessor. Code is KCS 403. I am covering first unit, and in first unit today the lecture that I will cover is microprocessor, evolution and types. First of all, let us understand what is microprocessor. So, as we all know, as I have already told in the previous lecture, that a microprocessor is a CPU on a single chip. That is, on a single chip, there will be CPU having register set, control unit and ALU. So, it is an electronic circuit, that is, we can say IC, electronic integrated IC, integrated chip, the circuit that controls all the functions of the CPU or central processing unit of a computer or other digital devices. The entire function of the CPU is controlled by a single integrated circuit that accepts the binary data. Okay, so binary data will be the input for this device. It processes that data according to the given instructions and then generates the output. So, the first thing is the input that we give to the processor. Second is this input will be processed and executed, and finally the output will be obtained. This processor contains millions of tiny components like transistors, registers and diodes. So, basically any semiconductor device is made up of what? Transistors, registers and diodes. So, likewise our microprocessor is also made of these components. The block diagram representing a microprocessor system is, this is a microprocessor. It can be any microprocessor, either 8-bit, 16-bit, 32-bit. Next component is the input, output and memory. So, these input, output and memory along with the microprocessor makes microprocessor complete system. Now, since we are talking about the evolution means how the microprocessors have developed from the previous times till date. So, basically the evolution of microprocessors is divided into 5 generations, that is first generation, second, third, fourth and finally the 5th generation. So, today we will talk about all these 5 generations, the features, the microprocessors, those were introduced in these particular generations. Let's have a look. So, when we talk about the first generation microprocessor, so the first generation microprocessors were introduced in the year 1971 to 72. So, this was the time frame when the first generation microprocessors were introduced. The instructions of these microprocessors were processed serially. Instruction is fetched, decoded and then executed. So, this is the special feature of this generation, that the instructions are executed serially. That is, the first instruction will be fetched from the memory, then it will be decoded and finally it will be executed. And the process repeats with other subsequent instructions. So, when an instruction of the microprocessor is finished, then the microprocessor updates the instruction pointer and fetches the next instruction, performing these operations for every other instructions which are coming in turn. So, when we talk about the names of the microprocessors introduced in this generation, in 1971, Intel created the first microprocessor, that is 4004. So, this microprocessor is very important since this was the first microprocessor introduced and it was in the first generation. So, the clock speed is 108 kilohertz. Intel 4004 was invented by Ted Hoff, Masatoshi Shima, Federico Fagin and Stanley Mazur. So, these were the inventors behind this 4004, and it was a 4-bit microprocessor, and with the only 4 bits as the word size, it could only represent signed numbers in the range -8 to +7. Yes, so with the 4 bits, we can represent only -8 to +7. This is the range, which is indeed very small. So it was not practically available for any use in the arithmetic operations calculations. However, it found applications in controlling devices. So small controlling operations were done using this microprocessor. Among other microprocessors of this generation, there was 4040, that is 4040 was advanced version of 4004. It was also 4-bit processor. So Intel 8008, which was 8-bit processor, was invented in 1972. This was another example of this generation. First generation processors were designed using PMOS technology. We all know that among the PMOS and the NMOS technology, NMOS is faster. So this first generation is made up of PMOS technology. Low cost and low speed are the features of this generation. These processors require a lot of additional support ICs. So in the first generation, so many peripherals were not available on the single IC, on the single chip. So to make the systems function properly, along with the processors available, few additional support ICs were also added with the main processor to make the complete system. Now we come to the second generation. It was marked by the development of 8-bit microprocessor from 1973 to 1978. Intel 8080 was the first commercially popular 8-bit microprocessor. So this Intel 8080 is also very important microprocessor, since it was the first commercially available microprocessor. And it was introduced by Intel in 1974. With 8 bits as the word size, yes, the size of this microprocessor is 8 bits. It could represent the signed numbers in the range of -127, 128 to +127. So this was the range. This was bit higher, not that much, but a bit higher than the first generation microprocessors. This is also not a good enough range for performing arithmetic calculations. So 8080, having the 8-bit word size, this microprocessor was used only for control applications. Some other microprocessors from this second generation was 6800 from Motorola, Z80 from Zilog. These were very popular among that at that time. In 1976, Intel introduced 8-bit processor 8085. This became so popular. This was from the second generation. In 1977, Intersil launched IM6100 and Toshiba launched T8190. So though these were 12-bit microprocessors. So basically this generation included 8-bit and 12-bit microprocessors. Yes. And when we talk about the first generation, it handled only the 4-bit microprocessors, basically 4-bit microprocessors. And on the later part of the generation, 8088 was a 8-bit microprocessor that was invented in 1972. Just after that, we came across these microprocessors. They were costly. The second generation microprocessors were costly as they were based on NMOS technology fabrication and also for their super fast speed. They were super fast. These processors had better interrupt handling capabilities. This was another feature, and could address large number of memory locations. Since these microprocessors had wide address bus, since the address bus width was higher, so it could address large number of memory locations and input-output ports. The second generation of microprocessor is defined by overlapped fetch, decode and execute steps. That is, pipelining came into action. What is pipelining? The different instructions went through these processes like fetch, decode and execution steps in the overlapped manner. Means when the first instruction had already been fetched and was under decode process, the next instruction could be fetched. Similarly, when the first and second instructions were being decoded and executed, then another third instruction can be fetched. So, in this way, at the same time, both the all the fetching, decoding and execution processes can go on different set of instructions. So, this is what is explained in these lines. When the first instruction is processed in the execution unit, then the second instruction is decoded and the third instruction is fetched. In this way, the overlapped fetch, decoding, execution can be done. The difference between the first generation microprocessor and the second generations are mainly due to the use of new semiconductor technologies to manufacture the chips. So, this we have already seen that the previous generation was fabricated using the PMOS technology, and this generation is fabricated, next generations are fabricated using the NMOS technologies and so on. Third generation, it was marked by the development of microprocessor from 1978 to 1980. Around 1978, Intel released 8086, the first 16-bit microprocessor. This is another important part, that in 1978, under the third generation, 8086 was introduced. With the 16-bit word size, it was possible to represent signed numbers in the range this minus 32,768 to plus 32,767. This was the range since the word size was 16 bits. And this is quite a decent range for performing arithmetic calculations. As such, this processor became very popular for not only being used in the control applications, but also for number crunching operations. Other variants of 8086 include 80186 and 80286. So, this generation used HMOS, that is high density MOS technology. Speeds of these processors were 4 times better than the second generations. This is another important factor. So, the fabrication technology used in this generation is HMOS, and this is again better than the previous generations. Another good examples of this third generations are 68000 from Motorola. It's a 16-bit processor. It's Zilog released Z8000, again a 16-bit processor. These are the most popular 16-bit processors. Above processors, these two mentioned processors are like mini computers. They possess high speed power product and high packaging density. Packaging density means the more number of transistors are integrated on a single chip. Number of pins increased up to 40, 48 and 64. So, the hardware increased in these microprocessors, but simultaneously the functionality of these microprocessors were far more better than the previous generations. These processors used segmented memory schemes. So, this is another important feature in the memory segmentation. What we do, that we divide the logical memory space into the various segments, and those segments are used to store the different kinds of data and codes, and that segmentation is useful in mapping the virtual memory to the physical memory, and effectively we can use all the physical memory available within the device. So, this is a very useful scheme for utilizing the whole of the available memory space efficiently. So, let us come to the next generation, that is the fourth generation. This generation came into existence from 1981 to 1995. In the early 80s, Intel released 32-bit processor, the Intel 80386, by using HCMOS, that is high density CMOS fabrication. With the 32-bit size, it was possible to represent signed numbers in this range. That's a very good range, which is a quite large range for performing arithmetic calculations. If floating point notation is used, it can represent much larger numbers. As such, this processor became very popular in the CPU in computers for number crunching operations, that is for complicated operations. So, in the fourth generation, few examples that can be quoted here are Motorola came out with the 68020. It was a 32-bit processor. Again, Intel released 80486, which was basically an 80386 processor and 80387 numeric coprocessor on the single chip. So, these two, when available together, that the functionality of these two together can be compared with the functionality of this single microprocessor. So, Motorola released 68030 again. In the early 90s, Intel released 80586 by the name Pentium processor. It is extremely fast in performing arithmetic calculations and executing instructions. This generation supports increased number of addressing modes. So, what is the addressing mode? Addressing mode means that how the operands are presented in the instructions. That is the addressing mode. How the operands are available, how the data is available, that presentation is known as the addressing mode. How the data can be addressed, how the operands can be addressed. So, there are when we talk about the addressing modes in general, there are the few addressing modes that can be mentioned are register addressing mode, immediate addressing mode, and the direct addressing mode, implicit addressing mode. So, these are some general addressing modes available with any of the microprocessors. Now, finally, when we are talking about the fifth generation, from 1995 till now, we are in the fifth generation. This generation has been bringing out high performance and high speed processors. After 80856, Intel came out with a new processor, namely Pentium processor, followed by the Pentium Pro CPU. This is very important. And what is the specialty with this Pentium Pro CPU? It allows multiple CPUs in a single system to achieve multiprocessing. Other improved 64-bit processors are Celeron, Dual, Quad, Octa-core processors. The present day computers based on the microprocessors are already faster than the mini computers and sometimes mainframe computers of the yesteryear, and they are available at a very small fraction of the cost of such mainframe computers. So, this is yet another features of the fifth generation. Intel made improvements to provide higher speeds, though the higher speed is another feature. Examples include Pentium 2, Pentium 3, which have 64-bit data bus. So, these are being widely used in the modern computers. System can run on new operating systems. This is another feature. Linux, Unix and Ubuntu, they can be supported on the latest microprocessors. Pentium processors are available in wide range of clock speeds. Pentium is very fast, executing approximately 2000 MIPS. When we talk about the microprocessor types, so we can say there is vector processor, array processor, scalar and superscalar processor, DSP, that is digital signal processing chips, ASIC, that is application specific ICs, RISC and CISC processors. RISC is reduced instruction set computer system and CISC is complex instruction set computer system processors. So, when we talk about the vector processors, it is designed for vector computations and it is an array of operands. It is the process of using vectors to store the large number of variables for high intensity data processing. Few examples are genome mapping, GIS data, these are the examples, and the vector and some vector processors are IBM 390, DEX, VEX 9000, etc. Array processor or SIMD processor. What is SIMD? That is a single instruction multiple data processor. So, these are those processors which are expert in analyzing the different data, a lot of database. That is, for example, image processing, RD rendering, speech recognition, networking, DSP functions. all these applications requires a huge set of data, huge set of operands. When we talk about the scalar and the superscalar processor, this processor which executes the scalar data is known as the scalar processor, and the superscalar processor executes more than one instruction per clock cycle, and it has multiple pipelines. So this is the basic difference between the two categories. When we talk about the digital signal processors, these are used to process the signals in the digital form. Applications of DSP are audio signal processing, digital image processing, video compression, audio compression, speech processing and recognition. Digital signal processors are Motorola 56000, etc. Okay, so this is very important in the VLSI modern applications. RISC processors is a reduced instruction set computer. In this, the instructions are not complex. It is used in high-end applications such as video processing, telecommunications and image processing. When we talk about the CISC processors, the full form is complex instruction set computer, as I have already discussed, and the instructions in this processor are complex, and that is hence the name complex instruction set. It requires an external memory for calculations. So the memory load and unload operations are being done in this category. CISC architecture is used in low-end applications such as security systems, home automation. When we talk about the application-specific integrated circuits, it is implemented for special functions or applications. So in this way, the microprocessors can be categorized into these 6 categories, or we can say 7 categories, including this RISC and CISC processors. So when we talk about the evolution of microprocessors, we are with the 5 generations, first, second, third, fourth and fifth generation. And when we talk about the types of microprocessors, then we are here with the 6 categories of microprocessors. Thanks for today's lecture.